Soalan 8, diethylamine C2H52NH is a weak base. Okay. Mesti weak tau. Sebab bila ada value Ka dengan Kb means itu adalah weak acid base. A 0.01 molar solution of diethylamine has Kb of 9.6 times 10 to the power of minus 4. Calculate the pH. Soalan bagi Kb. Bila soalan bagi KB, confirm lah kita kena buat ice table. Okay, so figure out your ice table. Untuk base, awak wajib tambah dengan water. Okay, sebab kita nak ada present OH minus dekat belakang ni. Question 8, diethylamine C2H52NH is a weak base. Okay, so remember class, whenever there is a mention of Ka or Kb, that means that it is a weak acid or base. Okay, and we should be doing the ice table. A 0.01 molar solution of diethylamine has Kb of 9.6 times 10 to the power of minus 4. Calculate the pH of diethylamine. So we've got two formula to calculate the pH. So the first one would be pH equal to negative log H plus, or we're going to use the formula of pH plus POH equal to 14. Okay, so first thing, we must do our ice table. So remember that we don't have all the ice for the water because it is in liquid phase, and for the reactant. Okay, so we've got the initial concentration as 0.01 molar, and the product would be 0. So minus X plus X plus X. So the equilibrium would be 0.01 minus X. This one would be X and X. Second step is to write our Kb expression. So insert the value for Kb and the volume of this concentration at equilibrium. So that would be X squared divided by 0.01 minus X. So remember that for this X denominator, you have to figure out whether it is significant or not by using the alpha significant formula. So that will be the square root of all the Kb divided by the initial concentration of 0.01 molar. So the alpha would be, times the 100%. So the alpha significant would be 30.98%. So it is really higher than 5, right? So this X, okay, is significant. Since we already determined that the X denominator is significant, so we must proceed with the quadratic equation. So then we will be able to get the x1 with this value 2.66 times 10 to the power of minus 3, and x2 negative 3.61 times 10 to the power of minus 3. So same as chapter 5, we need to figure out which x will produce both positive values when substitute into the ice table. So notice that this x2 has a negative value in front of it. So for sure, it cannot be used for these values of concentration of the product. So by the hook or the crook, we're going to choose x1 as our change. So our concentration of hydroxide ion would be 2.66 times 10 to the power of minus 3 molar. So the last step is to find the pH. Okay, so first I'm going to use the formula for the auto ionization of water. So we're going to determine the concentration of hydrogen ion directly. So 1.0 times 10 to the power of minus 14 divided by 2.66 times 10 to the power of minus 3. So that would be 3.759 times 10 to the power of minus 12. So we're going to use this formula, and you need to include your concentration of hydrogen ion. So our pH will be 11.42. And the other way, is to use the formula of POH equal to negative log concentration OH minus. So our pH would be 2.575. Now substitute this value of POH into this formula. So our pH would be 14 minus 2.575. So the final answer would, there is a difference about 0.01. So we don't really care about that. Okay, as long as you have this 11.4 as your pH and the final answer.